All right, let's just dive right into this explainer. We're looking at the Vibrown's course, Clinical Cognition from First Principles. I'm super excited to get into this today because it's actually a dual track setup. So whether you're a practicing clinician trying to really hone your craft, or maybe you're a techie building the next wave of medical AI, this is totally for you. We aren't just looking at medical conclusions here. We're getting into the actual operating system of the mind. We are exploring how clinical reasoning truly moves from a raw observation to a final diagnosis. Which brings us to a massive question. Why does the reasoning behind a diagnosis usually stay invisible? It's a brilliant hook, right? It introduces what we often call the black box of clinical intuition, and it sets up the exact problem we're tackling today. Because think about it. When an expert physician arrives at a diagnosis, the internal mental gears turning to reach that conclusion are rarely documented. The trace just stays entirely invisible in the final chart. So the very first thing we have to do is figure out why this happens, and more importantly, what it looks like when we finally force that trace out into the open. So here is our roadmap. This is going to guide us from the mechanics of a single medical decision all the way up to system-level clinical wisdom. We'll hit making clinical reasoning visible, then the core cognitive engine, auditing biases and patient advocacy, systems thinking and mastery, and finally wrap it up with cognition meets evidence.
Okay, Section 1. Making clinical reasoning visible, specifically focusing on the Socratic loop.
Let's start with the foundational concept here. Making that invisible trace of a diagnosis visible. The primary engine for doing this is called the Socratic loop. What's truly fascinating is how this method forces that invisible reasoning trace out into the light. By using AI that actually questions you rather than just handing you the answer, it sets up these really powerful constraints. It forces the learner, whether we're talking about a medical student or a machine learning algorithm, to make a genuine, documented attempt before the solution is revealed. And doing that profoundly changes what is actually retained. This kind of guided discovery, it's the absolute bedrock of the whole framework.
Moving right along to Section 2, the core cognitive engine, covering lessons 3 through 9. Let's zoom in to the micro level and see exactly how we get from raw findings to a stress-tested diagnosis.
This is about building the fundamental cognitive loop that every medical professional relies on. We break down the mechanical stages required to build a really robust differential diagnosis. Because you don't just jump to an answer, right? You move from raw findings to a stress-tested differential, then to a probability-weighted differential, and finally, you do a self-critique pass. That last step is absolutely vital. It turns the discipline inward on the reasoning itself, making sure the entire thought process stays structured and completely auditable. Now, when you run this entire engine end-to-end on a single case, it forms what's called the master protocol. What you get is a complete reasoning trace read back as a single artifact. So instead of a bunch of disjointed notes, you suddenly have this comprehensive map of exactly how the conclusion was reached. We can actually examine it. We can check if the logic truly holds together from start to finish and ensure absolutely nothing falls through the cracks. All right, Section 3, auditing biases and patient advocacy, finding the failure modes. Because look, a cognitive engine is really only as good as its stress testing. If we can map out the reasoning, it means we can also map out exactly where that reasoning falls apart. We can unpack 5 distinct failure modes by looking at the failure surface from a few different angles. For instance, what actually happens at the exact moment you commit to a diagnosis? Or what if the single, load-bearing finding you built your entire case on is flawed? How are you distinguishing signal from noise? Where's the distortion happening during handoffs? And finally, doing a full retrospective audit ensures we catch these really subtle biases before they can cause any real harm. And you know, this isn't just about the clinician who produced the trace. This is exactly why structured longitudinal state logging is essential patient advocacy. If you can translate your reasoning trace for the next person handling the case, you are actively protecting the patient from communication breakdowns. You're making sure all the nuance of your clinical judgment doesn't just vanish the second your shift ends. I absolutely love this next concept. It takes failure mode and effects analysis, which is a strict engineering safety principle used to build airplanes and software, mind you, and it maps it directly onto clinical cognition. It's treating the clinical process with the exact same rigor as complex systems engineering. You're ensuring safety at every single step, rather than just crossing your fingers and hoping for a good single decision at the very end. This also teaches us a crucial distinction when we look at analytics at scale. We have to recognize exactly where analyzing a single patient record genuinely diverges from population-level analytics. Applying population reasoning to a single highly unique patient, or vice versa, is such a common trap. Making this reasoning trace visible helps us understand exactly when to use which mental model, which can honestly save you from a critical analytical error. Which brings us to Section 4, Systems Thinking and Mastery, covering lessons 10 to 13. We are shifting gears now from single-agent reasoning to how this whole ecosystem operates across entire organizations and lifetimes. We are establishing a massive metacognitive shift here, basically turning this same machinery inward. This means taking our multi-axis confidence checks and our self-critique and using them for clinical reasoning that continues far beyond just one single diagnosis. It is all about understanding your own thought processes on a meta level so you can continuously refine your craft over time. Think about the sheer chaos of massive healthcare systems. To actually scale safety, we need structured handoffs, we need teams collaborating on distributed differentials, and we absolutely need systems-level root cause analysis for when things go wrong. As we advance, we scale our core engine into multi-agent workflows. Plus, we layer on precision medicine, checking applicability, resolving conflicting evidence, and deeply weighing patient preferences, all while documenting any deviations from standard care. Ultimately, this operating system is tackling mastery itself. It's attempting to capture that highly elusive tacit knowledge and formalize true clinical wisdom. We learn this vital closing habit, being able to tell real hard-earned expertise apart from a mere heuristic shortcut that just happens to look like expertise on the surface. Finally, Section 5, Cognition Meets Evidence, the missing puzzle piece. To close out our explainer today, we need to understand where this entire operating system fits alongside traditional frameworks. Specifically, we need to look at its relationship with evidence-based medicine. The relationship between the two is perfectly complementary. EBM asks, can I trust this external evidence? While clinical cognition asks, how did my brain get from the findings to a judgment in the first place? They aren't sequential. You can start with either one, really. But to have a complete, functional picture of modern medicine, you absolutely need both. I should also quickly mention that the course features 5 optional elective modules. These cover everything from N of 1 research and journal reading, all the way to community medicine and longitudinal cross-case learning. So plenty there for those of you who are ready to dive even deeper into the material. I'll leave you with this final, provocative thought to really challenge how you view your own expertise. As you build your skills over the years, your reasoning naturally compresses into intuition. But when the stakes are incredibly high, how will you audit your own compressed intuition? Unpacking that trace is exactly what clinical cognition is all about. Thanks so much for joining me on this deep dive.